Hey, this video is over Introduction to Redox Reactions and Determining Oxidation Numbers. Alright, so a redox reaction is also called an oxidation-reduction reaction. It's just shorter to say redox, so the red part comes from reduction and the ox part comes from oxidation. And so it's redox reaction. Oxidation is when there is a loss of electron, and reduction is when electrons are gained. So sometimes it can be difficult to see if a loss of electron happened or if electrons are gained because it's a negative thing. So the oxidation number for oxidation will go up, and for reduction the oxidation number goes down. So before we can really talk about redox reactions, we have to be able to determine the oxidation number for substances. So we will come back to this slide soon. Alright, so assigning oxidation numbers. The oxidation number of a neutral atom or compound is 0, and a compound fluorine is always -1. Oxygen is -2 unless it's in a peroxide. Hydrogen is +1 unless it's with a metal, then it's -1. The sum of all the oxidation numbers must equal the overall charge. So if you don't have these in your notes yet, write them down. This is the simplest way to explain it. We could go on forever with different oxidation rules, but this is the simplest way to start. All right, so pause the video if you don't have these written down somewhere so that you have them in front of you while we go through the examples. All right. For the first few, I'm just going to shrink this down so that we still have it on the screen, but eventually it's going to have to come off because I have a bunch of examples on here. All right, so for sodium, this is solid sodium. It does not have any charge up here, so the oxidation number is 0. Rule number 1 says the oxidation number of a neutral atom or compound is 0. This is neutral. There's no charge here. Now this one is going to be equal to the charge because it says that the oxidation number is 1. That's what this means, plus. All right, so next we have O2. Just like the sodium example right here, there's no charge up here. So this oxygen can't carry a charge. If it did, like let's say that this oxygen was -2, then there would be a -4 charge here, but we don't see a -4 charge, so that means that both of those oxygens have to have an oxidation number of 0 for it to not have a charge up here at all. All right, carbon dioxide. Rule number 3 says oxygen is -2 unless it's in a peroxide. This is not a peroxide. We will get to peroxides here in a little bit and I'll explain what they are. But for right now, if oxygen's not by itself like this, then it has to have an oxidation number of -2. So if this oxygen is -2, so I'm going to write oxygen -2, then that means that over here we have -4 because we've got 2 oxygens. Now the very last rule on these oxidation rules says the sum of all the oxidation numbers must equal the overall charge. So the overall charge on this compound on carbon dioxide is 0. It doesn't have a charge. So if this side is -4, that means that this carbon has to be +4 in order to add them together to find the sum, right, to equal 0. So that means that carbon is +4. All right, next we have magnesium fluoride, and the second rule says that fluorine is always -1, so fluorine is going to be -1, right? And then if fluorine's -1 and we've got 2 of them, then that means that's -2. And again, there's no charge on this compound. It's 0 up here, so that means that magnesium has to be +2 in order to get 0. All right, and then sometimes you'll come across stuff that doesn't quite fit on the rules, so you're going to have to rely on what you know. And so I'm going to start with chlorine. Chlorine is going to be -1. So if chlorine is -1, that means that this whole, for all of chlorine is -4, because chlorine's -1, we got 4 of them. The sum of all this has to equal 0, so that means that this carbon is going to be +4. Because 4 minus 4 is 0, and that's the charge, so that's how we have to do that. All right, NO2. Oxygen is -2. So that's going to be -4. So that means that nitrogen has to be +4 to get a charge of 0. There's no charge up there. Okay? NO2 negative. Oxygen -2. So that means we've got -4. Now this time we do have a charge, and it's a charge of -1. So we want -1 left over. So nitrogen has to be +3 because 3 minus 4 gives you -1. So that charge matches up here. Okay, so nitrogen is found to be +3. All right, NO3 minus nitrate. Oxygen again is -2. So -2 times 3, because we have 3 oxygens, is -6. We want one negative left over, right? We want one negative left over because of this negative charge right here. So if all those oxygens is +6, and that means nitrogen has to be +5, because 5 minus 6 gives you that -1 charge left over. All right, dichromate. So oxygen again is -2. So that's going to be -14. Now we want 2 negatives left over this time. So that means that all of chromium has to be +12. And so that means that each chromium, because there's 2 of them, each chromium is going to be +6. All right, hydrogen. Now this is hydrogen peroxide. So because I told you that, you know that this rule from rule number 3 says oxygen is -2 unless it's in a peroxide. So this is a peroxide. That means that oxygen is going to be -1. Now how you could tell this is a peroxide, if it's bonded to something that's in group 1 or 2 off the periodic table, then you need to check it. The metal or hydrogen will always be the charge that you find on the periodic table. So what the charges were back in the beginning of chemistry, straight from the periodic table. So hydrogen is +1, right? Okay, so if hydrogen's +1 and there's 2 of them, that means that this has to be +2. And then so oxygen is going to be -2 for both oxygens. So that means each oxygen is -1. So on this next one, because this is from group 1, we have to check this one. It might be a peroxide. So sodium is going to be +1, and so that makes it +2 because there's 2 of them. So each sodium is +1. And then oxygen would then have to be -2 to get a charge of 0 here, but since there's 2 of them, each oxygen is going to be -1. So this is sodium peroxide. All right? Okay, so beryllium oxide here, this beryllium oxide compound, beryllium's in group 2, so again you got to check it to make sure to see if it's a peroxide or not. So beryllium is going to be +2. So that means that each one of these oxygens has to be -1. So this is beryllium peroxide. Okay, and then here we have another group 2 metal, magnesium, and it's +2. So that means this oxygen is -2 because there's only 1. So this is not a peroxide, it's just magnesium oxide. All right, H3PO4. So oxygen is -2, right? And so -2 times 4 here is going to be -8. And then we have +1 times 3 is +3. So we need to get a charge of 0 here. So that means that phosphorus has to be +5. So whenever you write down the oxidation number, you need to make sure that you write down the oxidation number of one of them, not of all of them in the compound. So see here how I have oxygen is -2, and I have hydrogen is +1, even though it comes out to +3 because there's 3 of them. So when it asks for the oxidation number, it's not asking for for all of them of that type. It's asking for only one of them. So oxygen's -2, hydrogen's +1, and phosphorus is +5. All right, so that brings us back to redox reactions. So if we look at this simple redox reaction, let me shrink this down a little bit. Okay. If we look at this, then we can find the oxidation numbers for each of these. So the oxidation number for this zinc is going to be 0 because there's no charge on it, right? There's no charge up here. And the oxidation number for this copper is 2+. The oxidation number for this copper is 0. And then the oxidation number for this zinc is 2+. And we can then look and analyze and see what's happening. So the zinc, okay, went from 0, from an oxidation number of 0 to 2+. So because of that, it was oxidized. And I know that because I know that when the oxidation number goes up and went from 0 to +2, then that means oxidation occurred. Okay, and then on the other end here, copper went from 2+ to 0. So the number went down, so it was reduced. All right. So how did copper get these electrons? It's gaining electrons, right? Because the number went from 2 to 0. So it's gaining negatives to get down to 0. So where did it gain its electrons from? It gained it from zinc. Zinc lost 2 electrons and copper took them. So this, when oxidation reduction reactions occur, they have to occur together. And the electrons go from wherever something is being oxidized to whatever is being reduced. They have to happen together. They can't, one doesn't happen without the other. So now one thing that they throw at you that confuses a lot of students are the terms oxidizing agent and reducing agent. So I like to talk about a travel agent before I tell you what they are. A travel agent helps you book your flight, books your hotel room, get you tickets to any event you might want to go to, and whatever, but they don't go on vacation with you. They don't travel with you. So a travel agent just makes you, like, assists you in traveling. Well, an oxidizing agent and a reducing agent are the same thing. A reducing agent helps something get reduced, and an oxidizing agent helps something get oxidized. So the reducing agent is whatever is undergoing oxidation because it's losing the electrons. They get taken up here and allow this to get reduced. So whatever is being oxidized is the reducing agent. So this would be the reducing agent, and this would be your oxidizing agent. All right, so let's try to look at some examples of this. You'll find that many of these on the worksheets that I've given you are not balanced. We're not going to balance these this year. It can be rough to balance some of the harder ones, so we're just going to wait on that for AP Chem. But you should be able to tell me which substance was oxidized and which was reduced. So if we look at these and we assign them oxidation numbers, the oxidation number for this guy right here is going to be -1, and then oxygen is -2. And so that would be -4 for all of the oxygen over here, and we want one negative left over, so that means this is +3. Iodine here is 0. Oxygen is -2, and nitrogen will be +2 because they have to add together to give you the overall charge of 0 there. So if we look at what changed, iodine went from -1 to 0, so it increased, so iodine is being oxidized. And then nitrogen went from +3 to +2, so it went down, so it was reduced. And so you could also say that iodine is the reducing agent while nitrogen is the oxidizing agent. All right, one more example. I have permanganate, and this thing is obviously not balanced. The oxygen disappeared, so it must not be relevant in terms of what's being oxidized and what's being reduced. We just have to figure out what the oxidation numbers for everything are. And so oxygen is -2, so that's -8. We want one negative left over, and so that means that manganese has to be +7. Chlorine here is -1. Manganese here is going to be +2, and chlorine here is 0. So manganese went from +7 to +2, so it was reduced. And then chlorine went from -1 to 0, it went up. -1 is smaller than 0, and so chlorine is oxidized. This takes a little getting used to, but it really clicks kind of fast if you just stay at it for a few minutes.